Let's solve the related rates problem in page 296 in our workbook. So this will be much like the one we did on the previous page. A stone is dropped into a calm body of water, causing ripples in the form of concentric circles. The radius of the outer ripple is increasing at a rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing? So the first step they have us do here is to identify all of the variables involved in the problem. So there are kind of two different things that are changing in this problem. We've got the radius of the ripples, and we've got the area of the circle that is formed by those ripples. And both of these are changing over time, so nothing in this problem is remaining constant. And the rates that we're given and the rate we want to find. So read the problem and come up with two rates, one of which we're given and one of which we want to find. Well, we're told that the radius is increasing at the rate of 1 foot per second. So the change in radius over time is equal to, should it be +1 or -1? The radius is increasing, so we're going to call it +1. And what we want to find is we want to find the rate of change of the area. So dA dt is equal to question mark. And the other fact that they're giving us is that at the specific instance that we're curious about, R is equal to 4. Okay? So now we want to write an equation, often a geometric formula or trig equation that relates all of the variables in the problem. So what do we have? What do we know as a formula that relates the radius and the area of a circle? Well, we know that the area of a circle is equal to pi r squared. And step 5 is to differentiate this formula with respect to time. And so that gives us dA dt is equal to 2 pi. Pi is a constant, so we multiply by 2, reduce the exponent by 1, and then we need to add in that factor of dr dt. So here's the relationship between the change of area over time and the change of radius over time. And it also depends on the radius at that moment. Notice that this is a relation that occurs throughout the process. Every moment the circles are getting wider, this is the relationship between the change in area and the change in radius. But we're interested in this specific moment when the radius is 4 feet. Okay, so let me do this. I'm going to take dA dt and then I'm going to substitute in dr dt because that is something that is a consistent change in the radius. So this is saying that dA dt, I'm going to substitute in 1 for dr dt. So this is equal to 2 times pi times the radius. This is a relationship between the change in area and the radius at any moment in time. But since we're curious in the specific moment where the radius is 4, we're going to substitute 4 in, and we're going to get 8 pi as the change, the instantaneous change in area at that specific moment. And once again, what is the units that we want to express this in? The rate of change of an area over time. So we want it to be a fraction where the numerator is the units we use to talk about area, and the denominator is the units we use to talk about time. So we're going to represent area in square feet, and we're going to represent time in seconds. So the change in area over time is 8 pi square feet per second. Okay, so I hope this is feeling like a pretty routine operation at this point, especially when you have kind of that process where you can go through step by step of identifying all of your variables, identifying the rates you know and the rate you need to find, finding an equation that ties them all together, and then differentiating that so that we can solve for the change of the rates. All right, we'll do more examples starting in the next video.